Right, folks. Well, it's another set from our same trade customer as yesterday, who had that corkcoder repair with the LCL economy, LCL communicators NI44TDX. So here's another corkcoder repair. We did this. Mr. Chippie and I have discussed this before starting on this video. One of the things this radio is supposed to be doing is jumping to channel 9 whenever it feels like it. So we initially were thinking, well, does it, because it starts on channel 9, so is it doing itself a reset? We were thinking along the lines of perhaps it has channel 9 as a channel 9 switch, and perhaps the switch was leaky or something like that, but there you go. So I think the best thing to do is to run this through the tests and see whether it plays up during that period. Sure, that's not the mic these came with. So it's an 80 channel set. It's under PR2797. So it's FM CPT and FM UK for UK use only. It's not a multi-norm. So I've got no specific instructions how to tune this, so we'll assume that it's being used as an 80 channel set and tune it on channel 1 of UK. So all these tests will be, we'll go channel 1 CEPT, channel 40 UK and channel 1 UK. So we're in the centre of the band. It could be channel 40 CPT because that's going to be still the centre of the band. So this is how we're going to do the test today. It'll be done on channel 1. I had one of these in the cars at one time, and this scan is so disappointing. It scans the 40 channels of the band you're on, and then it goes back to where you were. So we just to prove it, let's just start the set on channel 20. Now press scan. Or do you have to hold it? Yeah. And that's it. It goes back to where you started. It doesn't scan all the channels forever and ever until it picks something up. What a disappointment. Right, back to channel 1, and we'll see what we can get out of it until it starts playing up. So put picture in picture on. We're on the wrong camera already. We've got no transmit, to be honest. No transmit. Let's go on the other band. No transmit. Okay, we'll put it on receive. So it'll be 2760.125. I wonder if it's a dry joint contender. Okay, put S9 on, and it's receiving fine. So let's see how fine it is receiving. Put the sound meter on. We'll plug the test gear. and it stopped receiving. I think it's dry joints. Let's take picture in picture off. I think it's dry joints. In which case it'll get passed over to Mr. Chippie. He's got the video microscope on his bench. I've shown you all that before. So usually the screen plates, and they hide the dry joints. I'll do some tapping and bashing around and see whether we get a change. Better put the soldering iron on. I don't think we're going to have the dry joints there. I think we're going to have the dry joints around here. So you can see it started the sets using processors, even though we're on an SRBP board. And we'll just make sure that these screws are tight. We don't have any microphony on top of the other snags. Alright, so see whether there's enough heat in the soldering iron to undo the speaker. Oh, it's got this DSP, ESP. I never have worked out what that's supposed to do, but it makes it sound crap. Is this extra board? Yeah, right. It looks actually like it's could be 2002 this from the date code. And just because it's the approvals 97 it doesn't mean the set is. So just before they've gone on to multi-norms. So because it's CE approved, we've got crystal filter on the receive. So you know it's not going to be like the receive of yesteryear. So I'll just see if I can see anything obvious before we pass it to Mr. Chippie. We do have vibrators on each of the bench to help find dry joints, but I'm not going to show that in use. When I was at Nottingham Radio, we had one stolen. We know who pinched it. So we're on channel 1 still. The signal changer is still on channel 1. Yeah, straight back. I'll pass this across to Mr. Chippie. We'll pause the video. Okay, Mr. Chippie's dealt with dry joints on this now. He's also seen that the fuse holder was iffy, and he's dealt with that as well, which may have been causing the set to go to channel 9 as it did a reboot. So I've no reason to go tapping around it. He's done some stuff on there. He's good at that. Well, does it transmit now? It does transmit now, so that's probably the end of our problems. We haven't started the tune-up on it, but we've so it's dry joints. Mr. C. Put that down because there's a fee for that when he does it. Okay, so instantly we've got 3.1 watt. So we'll go down, we'll start with by going up to channel 40. And then down to CPT channel 1. So there's no low power because it isn't a 2781 set. It doesn't have PA. Current consumption, let's go back to channel 1 UK. 955 milliamps. Deviation. Wallow. 1 2 1 2. Wallow. Can't get a tuning point. Wallow. Is there no audio on this? Let's put this set down to channel 1. Testing 1 2 1 2. No transmitted audio. Frustrating. I'll just put my finger on the mic pins. I think it's the microphone. The thing is, we don't repair mics. I've got no proof that's the right mic for this set, which is another problem. Because if that's an electret mic and it's not expecting electret mic, is this sending the voltage up to the mic? You know, so it's all those questions. We're just going to have to leave that for now. We're not going to do the VCO. Frequency. 276010. So we'll do this on channel 20 so that we know where we are. (27 79104). That's fair enough, but if we can trim it, we will. We can. It's got a trimmer. Let's just put that on. Right, we've got it on the screen. We've got picture in picture on. No, we've not got picture in picture on. So there's the frequency. Set that slightly high so it's got room to drop, which is what they do. The transmit meter reads what? Well, it reads 4. On receive, let's go back to channel 1. We've got S9 on the test set, so theoretically that's S9, and it is 35 microvolts. S meter socket not tested. Right, so we'll look at the synad. Very sensitive. 0.43. Zero 0.37. I think we can safely say 1. Squelch threshold and maximum. So maximum squelch. Oh, it never opens. And for when we get there, we'll do the other end. Put the signal generator to standby. Park is at 0.3 of a microvolt. Keep switching it off. Signal generator back on. Coming in at 0.7 with good hysteresis. So that's a good start. So we're going to tune this on channel 1 of CPT. Sorry, start again. Channel 1 of UK. So it's in the centre of the two bands. So here we go. So put that on the main meter, and I've not got the service notes out. We'll just go through it as we go. So it's going to have a power preset. None of that has made any difference. It was already at peak. I can't remember whether that's deviation or whether that's power, so we'll find out. That's it, that's 4 watts. So we'll go to the other ends of the band. .5 watts. See whether we can bring that up by altering that. That brings it to 3.6 watts. Well, before we do that, we'll pop down to channel 1. Still 4 watts, so 3.6, 4 watts, and then CPT channel 1, 3.6 watts. That's nicely balanced. It's not going to do 4 over the 4 all the channels. Good. So we don't know what we're going to. Still don't know what we're going to do about this mic. Put the monitor receiver back on. This is where I could waste so much time. What band am I on? EU. Testing 1, 2. So we'll open this up. Did that go in the works? No. So is this an ordinary mic or an electret? I think it's got to be electret with the size of that. Let's take the switch out. Oh, it's not wide like a normal mic. We're going to have to dig the circuit diagram out, aren't we? It's single pole like you get on a business radio. Unless it's a Midland business radio microphone. 1 2 1 2. I've got a brand new one of these on the shelf up there, but I don't really want to take it out of its box to discover what the mic is, but I may well have to. Right. So we've done transmit power, so we can't do deviation, and we need to find the meter. Now, is it that one? No. Is it that one? Can't see how it can be. No. Well, it shouldn't be either of these. That looks like squelch. It's that one. So it's reading 4. Let's make a note of this. So we've got preset there, and then we've got this subboard. We've got a preset there, preset there, preset there, preset there. So that's TX meter. We've got a preset under there as well. So I'll have to come back to deviation. See if there's anything we can improve on the receiver, which is absolutely excellent. So put S9 on the signal generator, and we'll see whether that is maximum recovered from the detector. No, it wasn't, so that's an improvement. Turn that squelch down. It's there. So go through the front end. I'm not expecting there to be any improvement with the set working this well. Bit of a bigger signal for this one. No. No, that's fine. Let's see what we've now got. (12 dB), 0.33, 10 dB, 0.28, 1 dB, 0.95. Let's get this squelch sorted. The fact I've fiddled around with things is now opening it full. So I bet it... Is it that one or what? Let's find out. Nope. Well, I didn't fiddle with that one, so it must be one of these two. Well, you know, what can I say about that? We've got exactly 100 microvolts, which is what I want. I'm going to have to find which one it is, though. So is that one. And that is exactly where we want it. I'll do a photo of this because we've not covered it like that. So that leaves us with deviation, which we can't do, and S meter, which we can do. So put S9 on the test set. Show you the attenuator instead of that. So we want to bring that up to 9. So it's either that one or that one. It's not that one. How can it be, you know, unbelievable? Well, it surely can't be the one hiding under there. So is that a single meter one? Yeah, it is. So what is the second one for transmit? So that's actually S meter. So now with it keyed up, it's still reading 4, but I'd like to know whether either of these affect it. Yeah, that back one. So that's TX meter. So theoretically that should leave either deviation or that one is. Good, we're getting there. Got to get to the bottom of the mic. That's us run out of time, so we'll leave it at that for there. Just got that audio situation to sort out. Alright, so a few hours later, let's take picture in picture off. I've taken a microphone off my own Midland 98 that we once had in a car, and this radio works on transmitted audio. So the customer's microphone must be faulty. So I've kind of stripped down the capsule to find the actual electret insert inside. Then I've gone in my shed and I have found a realistic walkie-talkie which is an AM and therefore illegal in the UK American model, and this has the same microphone unit in it. So if we take the wires off this and put the soldering iron on, which I should have thought of ages ago, we should have a mic that works, and it's exactly the right unit. I did look at another one, it was a bit bigger. I can bet my bottom dollar that current ones are smaller. Come on, soldering iron. So a lot of trouble. I said it's not something we do, but I didn't want the customer having to go out and find a microphone from somewhere. So it's the white wire to the right. These have built-in field effect transistor amplifiers, so you know, if this has been damp, it could have ruined the innards. They're not as straightforward as you think. Take that capacitor off. I can't believe it's exactly the same unit. But it is. So I needed to check it with a with another mic in case there was no power feed going up to the microphone. These need 1.5 volts. I don't know how it's fed out of the radio, but they need 1.5 volts. Right, just put my monitor receiver on. Don't know whether those pins are dirty, but now I'm not getting even transmit to happen. Hello. No, we'll have to come back to that. Okay, we're back with the video. Put the monitor receiver back on. Go into transmit. 1 2 1 2. I can't hear anything on that. What about you? We're not on the right channel, that's why. Trouble with these up down buttons, you know, as you're working on a mic, it's going to change the channel. Testing 1 2. Perhaps we've changed mode as well. Are we now on a different band? Yeah, we are. We're on EU. Try again. Testing 1 2. Testing 1 2 3. 1 2 1 2. Well, that's fixed it. Thank goodness. Now I've spent longer doing this mic than I did doing the radio. So see if we can kind of put this all back together. So far so good. At least it's got a plastic grease on the PTT. I dismantled the plug to see if there was a wire off. Of course it's rather crammed in that plug. Right, we'll be able to set the deviation. I've done a photo of this, so we'll just make sure I've got all my controls right. Because we owned one from, well, we bought 3. Because we've had them from new, I've got an instruction book. So I've been able to, in the past, do a high quality scan. Testing 1 2 1 2. Good. So I'll be able to put my microphone off my own set back, so we've now got a factory original mic, which, although it's now got the insert from a scrap AM walkie-talkie of the realistic variety, it's exactly the same insert as the one in the factory mic. And hopefully, if I go and get that from behind me, this is our mic. Make should sound, I'm not going to change the volume on anything, it should sound exactly the same. Testing 1 2, testing 1 2. Good. Sounds to me like it does. So we've just got the faff to put this back on. This is another thing, this looks like it's been damp, and this is why I was looking in here, because the slightest bit of damp and you're going to get corroded pins, and then the solder coming off. This cable is really thick and quite stiff, and it is on mine as well, and that doesn't help. I don't think we had much joy with the mic leads lasting that long. I bought 3 of these thinking that they'd got scan, which was the kind of scan you expect, where it goes on continuously till it finds a channel in use, but it just wasn't the case. It's just absolutely bizarre that it scans once. So we'll just do a final test on that mic. Helps me put my radio back on. And then we'll do the deviation with the test set behind me. 1 2 1 2, testing 1 2. Wallow, 1 2 3. That's excellent. So let's see what this test set makes of it. Put picture in picture back on. Put the main meter on. Wallow, wallow. It looks absolutely spot on, but I can't say, because the deviation meter on this test set doesn't always tell the truth. We'll just plug it into the test set behind me on the bench behind. Change glasses so I can actually see the meter on this one. Wallow. It could be slightly high. What conclusion did we come to as deviation? Do you know what? We didn't, did we? We didn't. It could well be that one. Well, if it isn't, we'll be fiddling and fiddling, won't we? Whoa. That's it. That was the one. So we'll turn that test starter off, and we'll plug back into this one. So you do seem to have 3 meter controls. I can't remember if we did the squelch on this. We did, didn't we? We did. I'll plug the extension speaker back in. So I've done a photo. So I'll colour these in later, the rest of them. So that was RF power. That is deviation. So we had S meter, squelch. Oh, I'm lost. I'm lost. I've just done so many different things today. All we can do is kind of start from scratch. I've got power there. So it takes meter. That's it. So that's power. That's it. That's power meter. That's power. So that's squelch. That's S meter. But they are interlinked. And I think that is yet another meter adjustment. But I'm not going to. I looked at the circuit diagram. And that's how it seemed. Let's just put a signal on the radio. So anything I unadjust, I can always adjust back. So I've got S9 signal on right now. So if I adjust that hidden preset, I don't know. They've glued that into a set position. So if we look at the manual, it's that one there. The trouble is, even though this is a first generation scan and at 1200 dpi, I mean it looks like VR1. And VR1 should be squelch. But let's just put the squelch in again. It's not, it isn't. We already know that's squelch. Let's put squelch to full and just check I've got this right. No, I haven't. What's changed? Oh, that isn't squelch then, is it? That's S meter. We already know that. So is that squelch? See, that's S meters because you've got multiple controls doing. So that they're all interlinked. So it isn't squelch at all. So squelch must be that one there. Well, I'm going to have to force the glue off it. That's great because now it's broken. Well, the top's come off, the preset's not broken. I'll have to take this subboard out. We'll pause this. Right, so looking at the circuit diagram, the preset squelch is VR1. It looks like it's VR1 and it's 20k. So can we see what this was that we took out? I'll tell you what, I'll put the meter across it. Luckily we have these cheap and nasty ones in stock. Yep, 20k. I could put this back without its top, because if you take the top off and unsolder it, you can take all the rest of this top out, so you can then use it as an ordinary preset. But at the end of the day, I want this to look like it did, and it looks like I broke it. it was glued, you know, what can you do? I'm not going to be touching these on the ESP board, and it's got a date July 01, so the fact that I came up with 02, didn't I, with a date for the radio, looks right. So let's see whether we can put this back in. It's only used as a rheostat in this circuit. In other words, only 2 pins are used. First of all, I'll just check that the spacing's right to go through the holes. And the answer is yes. We've lost a little pad which doesn't do anything. I'll leave that board dangling and we'll get this set up. So I want full squelch and I want the thing to close like that. Back it off, close. Well, that's great, it never opens. Not quite where I want it, but that's the best compromise. Right, turn the set off, put these back. So this ESP, all it seemed to do was make the set sound awful. According to the instruction book, it makes it appears it has better sensitivity by removing noise. Well, you know, we had 3 of these sets. Seems a lot of electronics for nothing happening. So that is definitely squelch. So you've got 3 presets. You've kind of got an overall meter preset, and then you've got RF and you've got S meter. So it's a bit weird, but we've finally got there. And that is deviation. Good. We'll scan that, and then that's another one on file. So we'll get a final figure now for this squelch. So turning the signal generator to standby, we'll show the attenuator controls. Set the squelch on the radio and put the signal generator back on. Straight in. That's coming in at 0.3. That's great. Probably worth the effort now. But it needed adjustment, and then you try and adjust it and it's so glued up it breaks. And although I haven't got maximum where I'd like it to be, we've gone from never opens to, let me give you a figure, millivolts, so at least it does open. So deviation, I can't be sure where it was before, but we've now got it 2.2 to 2.5 kilohertz. I think it could have been 2.5, so it's just that little bit, tiny bit too much. So mic repair, new electret, insert, off, scrap, AM handheld. That's why we have this junk around. So that is 4 and that is 100. TX current is our final test. Also had to clean the contacts on this mic because halfway through it stopped going into transmit. And unplug the extension speaker, and it's drawing 1.1. There we go. Right, we'll put the lids on it, plug it into the aerial, and see if there's any good or bad buddies out there. Right, so we had these, I said we had these 3 of these in our cars before we were doing these on the air tests and that, and they worked fine. They were totally reliable and dependable. We did have some mics go down. I didn't bother mending them, I just bought new mics and threw the mics away. The half times have changed. Let's press scan. That's like it's loose. I have to look back at that tomorrow. Well, it was pointless, wasn't it? Because there was nobody on. One on a Roger. Let's go over to EU. $19 a Roger. $14 a Roger. That sounds like AM. I don't know. He's not doing 4 watts from Italy. So what does the SP do? Makes it sound horrible. He sounds off frequency now, he probably is. Okay, we'll do an on the air test. So another long drawn out repair, dry joints, duff mic insert and a faff. Thanks for watching.